Can remember?
What is that?
This is 2023 October, November, paper 1, 2, and 2, 2. So you are now paper 2, 2. Have we done this question? This question? Looks like we haven't done. Yep. Okay, we go over that anyway. Okay, number 6, October, November 2023, paper 1, 2, paper 2, 2. Metal wire has a resistance per unit length of 0.92 ohm meter. The wire has a uniform cross-sectional area. Calculate the resistivity of the metal of the wire. Okay, calculate the resistivity.
Um,
Go to the formula first of all. Then you want resistivity, subject resistivity. Then resistance per unit length. Resistance per unit length
oh,
as your area. Put in your value. Calculate out. Okay.
yeah, I
Usually
got
it's
it.
two significant figure enough. Anything, any comment or any question to ask?
No.
No, okay, let's go to the second part. Part B. A battery of electromotive force E, that is a battery, and negligible internal resistance is connected in series with a fixed resistor. That's a fixed resistor. And a light dependent resistor. There's a light dependent resistor as shown in figure 6.1. The resistance of a fixed resistor is given. The intensity of light illuminating the LDR causes it to have a resistance of 1600 ohm. Voltmeter reading is given 6.4 voltmeter reading. Show that the current in LDR is 4 times 10 to the power minus 3 ampere. And show right, you know the resistance, you know the voltage across it, then calculate your I lor. V equals to IR lor. Can. Yep, yep, yep. You know this is potential difference is 6.4 given by the voltmeter. And there's a resistance. There's a resistance. Calculate how you get that lor.
Mm.
Calculate the number of free electron passing through LDR in times of 3.2 minutes.
Yeah, I forgot the formula already. Was it like NRT, is it?
Go to the formula lor. I equals to Q
Oh,
over
okay, okay.
T. Q is N times E. Right? Number of electron N is IT. That's your I. Right? Change into, sorry, in SI unit. T, 32 minutes, change it to second times 60. Then E is 1.6 times 10 to the power minus 19 from the data sheet. Copy out. Can.
Mm.
Okay. As part of the question we saw previously, calculate the EMF. Calculate E. Right? You know this is 6.4. So calculate the potential difference across this one, no? You know the current, can you get the answer?
Yeah, I'm solving.
We get
12.
your vote.
I got 12.
Okay or not?
Yeah, I got 12.
Okay, get 12, okay. Then try the next one, number 4. Careful with your writing. Right? You need to improve your writing. So it's just to get you to use the power formula. I square R or V square over R. Can get one by one.
Yeah, I got it.
Okay, good. The environment condition change causing a decrease in resistance of LDR. In B, the temperature of the environment does not change. State whether there is a decrease, increase, or no change. Right? Decrease in resistance of LDR. So intensity, is it increase, decrease, or no change? Yep, yep, yep.
Okay, the resistance decrease.
Intensity of light emitting diode,
Increase, right?
increase. Current in the battery,
Current increase.
yeah, we got total resistance decrease. Reading of the voltmeter, you don't have to give reason now. You won't
Also
give you the
increase.
mark. Reading of the voltmeter,
Increase.
okay, decrease. Okay, um, let's stop the new paper. Mm, Okay, let's try this paper. Right, this is 2022 May May June. Sorry. Okay, let's try this question this year. #31. A straight copper wire of diameter 0.42 times 10 to the power minus 3 meter has a number density of free electron of 8.5 times 10 to the power 28 meter minus 3. In a given time interval, a charge of 0.15 second move through the wire. What is the average displacement of the free electron along the wire in this time interval? Calculate the drift velocity first.
NEOT.
Can or not? What's the answer?
Uh,
Calculate the area. And I is NQAV. Calculate the drift velocity. I is Q over T. And Q is electron, so we replace with E and EA. Then now 0.15 Coulomb. That's your time T. N is given. That's your N. That's your E. That's your A that we have calculated. And after that, L is V over V times T. V times T. L. That's the answer. Can. Anything not clear? Can or not?
all right.
Okay, let's go to 32. What is the definition of potential difference across a component? This one is just a repeat question. This is memory work, helping you score.
Mm.
Yep,
Voltage across the component is wrong. I think
yep. What's the answer?
it's donkey, is it?
No,
Is it donkey?
no. Definition is standard. B,
Oh,
void,
definition. Yeah. Oh, okay. Yeah. I
void.
remember. No,
Energy
it's void.
transfer to the component per unit charge. Energy per unit charge. That must be memorized. Okay, what's the answer for this one?
Um, the gradient is the resistance, lah.
Oh,
Oh wait.
in gradient is
Oh, wait, no.
reciprocal of gradient is the resistance.
1/r, right? Uh,
Gradient is 1 over R.
very confusing.
You have to invert it because your resistance is V over I. This I over V. Yep. What is the answer?
Mm,
Right? A cannot be the answer. The answer is it will be a
A is
straight
definitely
line
wrong.
passing through origin. Current is directly proportional potential difference when the current in the diode is in one direction. Right, that one is too small. It must be a straight line passing through origin. So false again. Diode has zero resistance when the current in diode is in one direction. Right, false again. That one has large resistance. This one has resistance decreases. Resistance of diode depends on the potential difference across it. That's the answer, lor. Donkey. Okay.
Mm.
A wire has a resistance 30 ohm. Second wire is made out of the same material, has the same mass, and 3 times as long as the first wire. Right? Same material, remember that? What is the resistance of the second wire?
This one has to do with Young's modulus, right?
No, this one has to do with
No, no, no.
resistivity.
Oh, yeah,
Length,
yeah, yeah, yeah. That's
length, same material, same
oh, yeah,
resistivity,
yeah, yeah. Okay, okay.
then same mass. Then you have to use density to come in.
So, 3 times
Right?
as long.
Calculate for the first wire first. Use the resistivity formula. After that, replace since the area is not given, yeah, same mass, use the fact of same mass. So
Oh.
can or not? Can you get donkey?
Yeah, I got it. Yeah.
Okay, you have to replace the A with volume over length, then L square, then volume replace with mass over density. Mass and density constant, same material, so volume is constant. No need to go and calculate again. Then get this formula, and then this is the original one, this is the new one, then put in whatever is given here. Okay,
Mm.
a cell has internal resistance R and electromotive force E. The cell is connected in series with a emitter and variable resistor R. When R equals 10 ohm, the emitter reads 0.3 ampere, and R is 5 ohm, the emitter reads 0.4 ampere. What is the value of E? Use the formula, put in the value for both of them, and calculate E. This formula.
Okay. I got
And what is the answer?
5. What
Say again.
shit? Wait, wait. Donkey ah.
Yeah, donkey. Okay, anything to clarify?
Don't have.
Don't have, okay. The sum of current entering a junction in an electric circuit is always equal to the sum of current leaving the junction. Why is this? Kirchhoff's first law, lor. Right? It's a repeat question, very popular. Yeah, taking too long.
A.
A, lor. Okay. In the circuit shown, the temperature remains constant. In which circuit does the potential difference V increases with increasing light intensity?
Okay, teacher, the rectangle with the line one, right? Intercept, that one is a thermistor, right?
This one is a thermistor.
Ah.
This one
Then
is
the other one is the
LDR.
LDR.
This LDR. So thermistor
Okay,
doesn't come in
so
because temperature remains constant.
it's either C or B only, right?
B, this
Wait,
one becomes smaller. So how can
C. It's C.
you want the potential difference to increase? So light intensity higher, increasing. This one will be smaller. Same thing here. Light intensity increases. B will be smaller, right? Because his resistance will be smaller. So answer is donkey. That one is smaller, so this one is larger, no? Okay.
Teacher, but why do you choose to put the voltmeter at the thermistor?
Intensity of light increases. So resistance in this part will decrease. Oh. So more sharing, they are sharing this EMF. So this one will have greater voltage. V
Oh, that's not a voltmeter, is it? That's like greater voltage.
just potential different across that, that's all. Or you want
Oh,
voltmeter also can. Voltmeter doesn't matter. They just want the voltmeter reading to show greater voltage, that's all. One or
okay.
10 more minutes. Okay,
Yeah.
okay, we have finished this part. Let's go to another paper. Okay, this 20 February paper, February March paper. Okay, let us go to the electric current and DC circuit. Number 30, wire carries a current of 0.1 microampere. Potential difference across the wire is 10 millivolt. How much energy is dissipated in the wire in a time of 10 seconds? Current is given, potential difference is given. time is given, so energy dissipated. Right, power, energy divided by time. Energy or work done is power times time. Power is VI. Put in your value, convert it to SI unit. Right? V is 10 millivolts, so it's 0.01 volt. Micro, change to SI unit. Time is 10 seconds.
Yeah, I got.
Okay, answer is donkey. Right? Memory work only, this one. You can see very popular. Yep. Still not sure your physics yet.
What per unit?
Memory
Per
work only.
unit
A,
charge. Yeah, per unit charge.
energy per unit charge or work done per unit charge. The graph represent the way the current through a filament lamp varies with potential difference V across it. Is memory work. What is the
Sure,
answer?
but this one is the reciprocal.
Say again.
It's supposed to be V at the y-axis, right? Instead of this way.
No, this is the right way to represent.
Oh, right way.
This is the right way.
Okay, filament lamp.
Yep.
A.
B.
Wait, what? Oh,
Right?
yeah.
This
Mixed
Ohm's
up.
law for wire. This for diode. Right? Memory work, diode. Okay. Table shows the properties of two different wires, P and Q. Wire P has a cross-sectional area of D. What's the diameter of the cross-section of wire Q? Right? This one you use resistivity formula. 10. Can get the answer?
Okay.
Okay. A cell has a constant electromotive force. The variable resistor is connected between the terminal of the cell. The resistance of the variable resistor is decreased. Which statement about the change of the cell's terminal potential difference is correct? I have a picture of the diagram. No? That's the diagram. Or draw it up if you cannot picture it.
Um, donkey.
You are told the resistance of
Oh,
variable resistor decreases, right? There's an internal resistance inside. So basically, it's a potential divider. If this one decreases, then less share of the potential difference of the EMF. A. Yep.
A.
Right or not? Okay, not?
Yeah, the current increases. No more work done. Oh, okay, yeah, yeah, I get it.
Okay.
Because D and A is quite similar, because both say current increase. Okay.
B say terminal potential difference is increased because the current in the variable resistor is increased. Current increases, but this one reduce, decrease,
Oh, yeah.
right?
Yeah,
So you
sure.
have to be careful. Memory work, this one. About one
First
more
law
minute.
charge.
Anytime we will cut off.
B.
Okay. B. This one is a bit more challenging. 10 volt. Internal resistance. Current flow through is 0.45. Current flow through is 0.48. What is the value of R and R?
Uh,
Find the potential difference across here. Then find the potential difference across here. Then can find R. After that,